So I'm currently in the market for a pump, an oil pump to be precise, and I know what you're going to say, isn't that a pump right there? One that's already good to go, already made, and doesn't need any machining. And the answer is yes, but A, that would be too easy, and also it's not really the correct type of pump for what I want. What this is some type of centrifugal pump. Inside here there's going to be an impeller which spins very fast, and whilst this is great at getting high flow rates, they aren't really as suited for dealing with higher pressures, which is sort of what I'm looking at. I mean, nothing too big, but I don't think that this is the pump for the job. Now of course this is not a pump, it's the gear train on the back of the lathe that connects the two gearboxes together. But with a bit of repackaging, this is pretty much the exact same setup as a pump, a gear pump. And if you weren't already aware of them, these pumps are incredibly common, especially in hydraulics. And for what I need, it really does tick all the boxes. It's good for moving thicker oils, which is what I'm going to be using this for. They do well under pressure. They run on rotational motion, which is good for powering this, and they're relatively simple to make. And I really do mean it. I mean, pumps in general aren't that too complicated, but this one here is pretty simple. It's effectively two gears seated in a pair of bushings inside a housing with an outlet and an inlet, plus some sort of way to drive one of the gears, which will in turn drive the other. I guess for me it's a little bit less straightforward because this is one of those projects where I would really benefit from having a CNC machine to make some of the parts, especially the bearing blocks, but unfortunately I just don't have one. So that's one thing that I will have to worry about, but in general, they are pretty simple to make. Now in terms of materials and tools, I'm kind of working with what I got, which here really isn't a lot. I've got some aluminium offcuts which will serve as the pump housing, and in a perfect world, these would have been a little bit thicker. If they were, I could have done this in two sections, just a top and a bottom, but instead I am going to have to do this in three. Which should be okay, we should be able to make it work, but it's more of a chance for things not to align correctly, and more of a chance for it to leak. Now for the gears and the parts that are going to receive a bit of wear, I'm going to instead make them from steel. 1045 medium carbon for the gears, and high carbon tool steel for the plain bearings and the wear surfaces. I will say ahead of time that I would have rather had used bronze or maybe a PTFE bushing, but I think steel should be okay, plus I already had it on hand. It also helps here that this is precision ground, which will be pretty useful further on in the build. I also have a 14 to 16 teeth gear cutter because the gears that I'm going to be making are pretty small, and most importantly I have a set of shaft lip seals. As you can probably imagine, one of the gears needs a drive shaft that sticks all the way through the housing so I can drive it, and the lip seal should prevent any oil from leaking out. These should be good to about 10 bar of pressure, and thankfully whilst we are going to receive a bit of pressure, it's not going to be anywhere near that. At most, I think we should get about 20 to 30 psi. Although with that said, these pumps, or at least a properly designed one, should be able to handle anywhere from 2 to 3000 psi, which is why you commonly find them on hydraulic systems. Although it needs to be said that pumps that are intended for that need internal seals on the bearing blocks and also need pressure relief channels for diverting fluid to avoid overpressurizing the pump and causing damage. Mine obviously isn't going to have anything like that because we aren't going to see anything close to those sort of pressures. So if you've opened one of these before and you're wondering why my one won't look exactly the same as your one, that's probably why. And for what it's worth, I can kind of say up front that with this project, I can sort of take it easy. Because with this pump, flow rate and efficiency really doesn't matter a whole lot. All I really need is a pump that works and doesn't leak. And in fact, apart from a few documents and reference material, I was kind of making up the exact dimensions as I went along. So don't expect this to be optimal in any way because it really wasn't. With that said though, precision is going to be important here, and no matter the dimension, the parts will need to be made extremely accurately. So let's jump in and let's get it made. So the first thing we'll tackle are the gears. They're going to be made the same size as the bushings, so they're each going to get 14 teeth, which will equal 60mm OD. So I'll take the steel down to 16mm and also make a small shaft on the end, which will locate into the bushing. With the first side now roughed out, I'll get it out of the lathe and into the dividing head to cut the gear teeth. And that came out looking pretty good. I'll then get it back in the lathe and part it off, so I can then flip it, clean it up, and then machine the shaft on the other side. And that is the first gear now done. This is going to be the driven gear. Now the driving gear is going to be made the exact same way, although it does need a longer shaft to be made on one side, and that'll be so I can connect it to a pulley. And those are the two gears now done. I now start to work on the plain bearings, which is relatively straightforward, since the outside is already precision ground to the size that I need. So all I really need to do now is drill the inside to 19/64 of an inch, which is a bit over 7.5mm, and then ream it to 8mm. I'll then come and part them off a bit over 5mm long, and then I can take them down to the correct size later on. And that's 1, 2, 3, and 4. And they have a really good fit on the gear shafts. And this is roughly how they'll look once they're assembled. Now, as you can probably see, the high carbon steel bushings and the outside of the gears are going to be our main wear surfaces. And whilst all these parts can be hardened, whether or not I do harden them is going to be up in the air, because the truth is I don't expect them to see a whole lot of load or wear during use, mostly because we're only moving a small amount of oil, which shouldn't take a whole lot of force, and when this is in use it's going to be flooded with oil, so I can't imagine it's going to be experiencing a whole lot of wear. But if I really need to, I can always harden it at a later date. With that said, they're still not done yet. Parting them off left a pretty big burr, and that needs to be removed. They also need 1mm taken off one side to form a flat, and this will move the gears closer to each other so they can mesh. Now this should give you a pretty good idea of how they're going to sit in the housing. As you can probably see, this is a pretty good substitute for a bearing block when you don't have access to a CNC or a rotary table. So with the gears and the bushings now done, let's start on the housings. Again, it's all aluminium offcuts, so I'll first get them cut down and then cleaned up. And that's the aluminium pieces now cleaned up. The big one is going to be the base, which will feature holes for mounting it, and the two smaller ones will be for the gear housing and the top cover plate. So the first thing I'll tackle is the base. Now where I'm going to eventually place the motor is going to be a bit limited in height, so I am going to take a bit of material off the top. I'll then come in and drill some mounting holes. I'll then swap out the drill for an end mill, because what I want to do is create two flat bottom holes, and plunging in with an end mill creates an almost flat bottom. Flat enough for what I need here. I'll then swap it with a boring head and then take it to its final size. And this is one feature that needs to be done extremely accurately. What I want is a nice transitional fit between the bearings and the housing, and because I started off the bearings using ground stock, I know the outside diameter is exactly 16mm. So what I'm going to be aiming for is a hole that is about 10 to 20 microns under that. So I guess no pressure. Alright, so that is just under what I need. I think I'll dial in a tiny bit more and that should be just perfect. And that looks to be pretty much spot on. I'm not going to push it in all the way to test it, because if I do, I probably won't be able to get it out, and I still have the other one to do. So what I'll do now is I'll do the other one, and then hopefully it should all fit. And once again, that is a really good fit. The last thing to do on this side is going to be to make the mounting holes. Now the way that I'm going to try and make this all work is that I'm going to use the screws to hold everything together, but at the same time the screws are also going to be used as locating pins to help keep all the three parts aligned. So to make this work, I'll start by drilling part way with a 5.5mm drill, and then follow it up with a 5mm drill. The top half will get reamed to exactly 6mm, and the bottom will then get tapped for M6. I can then do that 3 more times, and then get it flipped over. Okay, so as you probably did notice, I did change the part just a little bit, in that I had to rebuild it. To put a long story short, the original mounting holes that I had made would have made everything a lot more difficult come time to actually mounting this in place. Plus, upon remeasuring it, I also realised that it didn't need to be this thin, so I was able to make it and the threads a little bit longer. I've also gone ahead and drilled a hole all the way through for the shaft. It's also worth saying that which gear you choose to drive and the direction that you are driving this from is going to change the direction of the pump. And we can get into that a little bit later. Now the final thing that I need to do on the base is to make a counterbore for the shaft seal. Now there were a few different styles that I could have gone for, but this style of lip seal is probably the most basic that I could have gone for. It simply mounts at the outside and it's held in place through friction. That is at least the plan, as long as I get the counterbore right. The datasheet here specifies a hole tolerance of 22 microns, which is not impossible, but it's very easy to go over if you're not careful. And unfortunately, I don't have any spare aluminium to work with if I get this wrong. And thankfully, that is pretty much spot on. I'll now get the part and then give it a wash in degreaser to remove any grease and chips, and then I'll leave it out to dry. Now the top piece is going to be made in a very similar way, although it is smaller and thinner. It also gets 4 holes drilled all the way through for the alignment pins. And the bores for the bearings also need to be made just as accurately as they were beforehand. Now the last big thing that we need to make is the housing for the gears. It's mostly the same process as before, except the holes go all the way through the block. Now this time, instead of being right on 16mm, what I want is to take it a little bit over to about 16.1. Doing this should give us a gap or spacing between the gear and the housing of about 15 microns, which is roughly the width of a human hair. Ideally, we would want it to be as tight as possible without it rubbing, and I think 50 microns is a pretty good target. And with the first hole now done, you can now see how great the fit is with the gear and the housing. That is pretty much perfect. With the second hole now done, I'll then come in with an end mill and mill a flat on each side in the spacing between the two bores. Doing this should help create a bit of space for the fluid to move from the gear teeth and into the nozzle. Alright, and that's the three parts that make up the pump body now done. Now before I do a quick test fit, I need to make up the 4 screw pins that will hold and locate everything together. Now the main thing that is important here is that the pin part is accurately turned down to exactly 6mm. Anything smaller than that and it won't properly align the parts. Now I probably should explain, I recently shattered my slitting saw blade and I don't currently have a replacement, so to make the slot I'll use a 2mm end mill, crank the RPM up and hope that it doesn't break. Alright, and I think they came out looking pretty good. And that is most of the parts now done for the moment. Now I'm currently doing a quick test fit just to make sure that everything fits together nicely, and so far I'm pretty happy with how it's all come out. Everything fits well and it slides pretty nicely. Honestly, it's all going a lot better than I thought it would. So what I need to do now is make an inlet and an outlet for the pump housing. Now as it is at the moment, I haven't settled on exactly what tubing I'll use in the end, and I don't currently have a whole lot on hand. In fact, all I really have is some 8, 3 and 5mm vinyl tubing. I think it's rated to about 40 psi, which in hindsight is probably more than enough. But at least for testing, I'm going to settle on 5mm, and if I need to go bigger, I can always do that if I need to. So the first thing I'll do is I'll get the inlets drilled and tapped. I'll also go ahead and get 2 hose connectors made up. Now initially I was going to go for brass, but unfortunately I don't have any, so aluminium will do, at least for now. And with that now done, let's go ahead and get it assembled. Now as I mentioned before, the bearings were made to be a little bit long, so I had to take them to the mill and get about 0.1mm taken off the end, just so they would fit correctly in the housing. I also could have sworn that I had some gasket paper lying around the workshop, but as it turned out, I didn't. So at least in a pinch, I'm going to make one up from some printer paper, and let's just try and see if it works. And once the top is put on and it's all screwed together, that is the pump now done. I know it's pretty basic and not the best thing to look at, but the real question is, does it work? So let's go ahead and find out. Now for testing, I'm simply going to drive it off a battery drill, and the fluid that I'll use is some engine oil, which is very similar to the oil that this will be pumping. Now I've got to say, on the first go, it wasn't off to a great start. As it wasn't the greatest at self-priming, but once I started to prime it with a bit of oil, it started to work quite well. It wasn't perfect, but the important thing is that it was pumping. Now initially the biggest problem was that we weren't getting a whole lot of suction, and we were getting a lot of air bubbles mixing in with the oil, which probably indicates a leak somewhere. Thankfully though, I was able to tighten the screws a little bit more, and that seemed to fix most of the problems. And as it is at the moment, it's doing a really good job at pumping oil to and from each container. So at least for my first attempt, I think this is a pretty good starting off point. Now at this point I think it's worth explaining how a gear pump like this works, because it may not work in the way that you think that it works. Now you may initially think that the gear teeth will pull the liquid through the middle, through the gear teeth, and then spit it out the other side. But what is actually happening is that the oil is being pulled around the outside, trapped in the space between the gear teeth and sealed off by the housing wall. And once it's on the other side, it's unable to move through the centre of the two gear teeth, so instead it needs to go through the outlet. And this is the reason why the spacing between the outside of the gear teeth and the housing wall had to be as small as possible. The larger the gap, the more leaking of oil that you'll get, and the pump will become less efficient. Now at this point, I am 95% of the way there, but as it is at the moment, I really can't finish the project until it works pretty much flawlessly. Because once I get this pump installed, I want this to work for years and years without any issues. So the first thing I'll do is I'll clean up the outside just to make it a little bit more presentable. Secondly, as you could probably imagine, the paper gaskets that I made didn't really do a good job, as probably indicated from the air bubbles forming in the oil and the leaking oil out the side. So I've gone ahead and bought some proper gasket paper, and this time I'll do a much better job at cutting it out to fit properly. And yeah, that is going to be a much better fit. I've also come in and added a reverse countersink to the inlet and the outlet to help the oil flow out and flow in a little bit better. I have seen another person do this and it seemed to work. I could also come in and reverse counterbore it, which I think is somewhat common on these pumps, but unfortunately the hole that I'm working with is only about 5mm big, and I don't really have any cutting tools that could do the job. And with the motor now back together and running, it is certainly a huge improvement over where it was before. We're getting a much better flow of oil and practically no issues with air bubbles forming in the oil. And also no leaks whatsoever, so the new gaskets and the lip seal are working perfectly. Now as it is at the moment, I'm running it at about 1200 RPM and it's only doing about 300 to 400 ml of oil per minute at the very most, which really is not a lot. Now this is not a problem with the pump design, it really is a restriction that is based on the inlet housing, which is only about 4mm big. And I am more than certain that with bigger tubing, we will be able to get a much higher flow rate. Now whether or not I'll change it will remain to be seen. Again, all I really need from it is for it to just work. Efficiency and pump speed really weren't a part of the design, which again, I mostly made up as I went along. I only recently just got my SolidWorks license back, so all the CAD work was done after the project. And for what it's worth, I don't have the flow sim anymore, so even if I did design it in CAD, doing a flow sim on this would have been out of the question. All this is to say is that I wouldn't use this as a good example of great pump design. It's a pump design that works, and one that will work for me, but it probably isn't the most efficient example out there. But the important thing again is that it works. Or at least we will see if it works when it comes time to putting this to good use. And that'll be at a later date. Until then, thank you very much for watching, I hope you enjoyed this video, and I'll see you next time.